Reinforced concrete. According to the Wikipedia, reinforced concrete, also called reinforced cement concrete and ferroconcrete, is a composite material in which concrete's relatively low tensile strength and ductility are compensated for by the inclusion of reinforcement having higher tensile strength or ductility. Uses of reinforced concrete. Reinforced concrete is produced when steel bars or wire mesh strengthening substance is immersed in concrete as matrix substance. Reinforced concrete is widely used in the construction of bridges, dams, and buildings. Now, let's look at the comparison and difference in properties of reinforced concrete. The properties of concrete, which is high compression strength, low stretching strength, and resistant to corrosion. The properties of steel bars and wire mesh, which is high stretching strength and corrodes much easily. Combine those both, we'll get reinforced concrete with the properties of high stretching strength, high compression strength, and resistant to corrosion. That's all from me. Thank you for watching. Move to the next session.
Okay, so for next, I want to talk about composite materials regarding fiberglass. As the introduction, fiberglass is produced when plastic, which is matrix substance, is strengthened with glass fiber, which is strengthening substance. For your information, matrix substance is a weak, soft, and easily burned plastic. The properties of plastic are reinforced by adding glass fiber, while the uses of fiberglass is in the making of helmets, car bumpers, and printed circuit board. Fiberglass is a very strong and durable material that will last for many years. They can withstand extreme weather conditions without cracking, chipping, or breaking. These are the properties of plastic. First, low stretching strength. Second, low heat and electrical conductivity. Third, resistant to corrosion. And fourth, durable. While for the glass fiber, first, high stretching strength. Second, low heat and electrical conductivity. Lastly, for the fiberglass, first, high stretching strength. Second, heat and electrical insulators. Third, resistant to corrosion. And fourth, durable. So that's all for now regarding fiberglass. We jump to the next point.
Optical fiber. Optical fiber consists of 3 layers. The innermost layer is the core that is made up of silica glass fibers. The core is encased in a second layer or cladding that is made up of glass or plastic. The outermost layer is made up of plastic that acts as a protective jacket. Optical fibers are used to transmit information and data in the form of light. Light moves through the optical fiber in a series of total internal reflection. The core and cladding have different refractive indexes to enable them to carry data in large capacity and to not be influenced by electromagnetic disturbance. This composite material has replaced the copper wires in video cameras and connect computers in local area network. Comparison and differences in properties of optical fiber. There are 2 components in optical fiber, which is plastic that has high compression strength and flexible. Also, glass fiber, which is low compression strength and hard. When we combine them, optical fiber will produce, which is high compression strength and flexible.
This is photochromic glass, or sometimes known as transition glass. It was discovered way back in the 1960s by the Corning Glassworks Corporation. Nowadays, photochromic glass can be found in the comfort of your room, in your cozy car seat, or even you are wearing it right now. A According to our textbook, photochromic glass is a composite material formed when the glass as a metallic substance is combined with silver chloride and copper 1 chloride as the strengthening substances. When exposed to sunlight, photochromic glass darkens. Try to imagine in a vast sea of glass molecule, usually a type of borosilicate glass, you can find 0.01 to 0.1% of it consists of small groups of silver chloride and copper 1 chloride ionic compounds. Each elements are bound to each other and has a face-centered cubic structure. UV ray has the ability to knock an electron off the chloride ion, turning it into chlorine atom, thus breaking the ionic bond it has with silver ion. If the electron is received by a silver ion, thus turning it into silver atom, the silver atom can attract more silver atom to form tiny microscopic specks of silver metal. This is what blocking some of the sunlight, specifically UV ray, from passing through. When the UV ray is no longer present, the chlorine atom regains its tendency to receive electron and it receives it from a nearby copper 1 ion. Then, a nearby silver atom donates its electron to the copper 2 ion, essentially turning the copper 2 ion back into copper 1 ion. Silver ion and chloride ion are attracted by a strong electrostatic force to form silver chloride, and the same goes to the copper 1 ion and chloride ion. Now, let's dive deep into the comparison and difference in properties of photochromic glass and its original components. The first and major component of photochromic glass is glass, which has the properties of being transparent, does not absorb UV rays, and not sensitive to light. The second and most important component is silver chloride, which has the properties of being transparent to visible light, absorb UV rays, and sensitive to light intensity. Both components are combined together to form photochromic glass, which has the properties of being transparent, absorbs UV rays, and the absorption of UV rays depend on light intensity.
Superconductor. Superconductor is a composite material that has superconductivity properties other than alloy, such as yttrium barium copper oxide (YbCO). This superconductor is used to make electromagnets that are superconductor magnets or supermagnets. To give you a better vision about these superconductivity properties, it includes no electrical resistance and does not allow magnetic field to penetrate into the material. So, if superconductor material is at the low temperature, it will produce no electrical resistance. Therefore, the electrical current is conducted effectively. Superconductor material also does not allow other magnetic field to penetrate because it creates its own strong magnetic field. The phenomenon of repelling both magnetic field is called Meissner effect. Additionally, superconductor magnets are light and have strong magnetic force, and basically involved in nuclear magnetic resonance machines and magnetic resonance imaging machines.
Wait a minute.
Comparison of superconductor. And finally, the comparison with original component is the normal material has high electrical resistance and magnetic field can pass through the material. Meanwhile, superconductor has the opposite properties.